But stuff like this, like dinosaur blood, is in such a limited amount. Your raw material is so limited. You don't want to get that wrong. You don't want to waste it.
Absolutely. And you don't want something that's going to go on for 25 years. But this is a situation which did go on for 25 years. A lot of people said, no, you've put your finger on it. You're looking at human genetics. You're putting exactly. Someone has coughed over the other side of the room, and those particles have travelled and landed on your specimen, and that was enough to ruin an entire study.
That's very rare.
That is very rare.
There are a lot of, and you can tell very quickly if that does happen, normally.
These ostrich proteins were found in 2017, but in 2018, a PhD student named Jasmina Weiman at Yale did further tests. These are the most comprehensive tests to date of the original 1997 dinosaur blood samples. More bone dissolving, so much chemical dissection, and looking at what was in there, looking at what was the residues left over. Everything was taken into account in the study. And she came to the conclusion that yes, Mary, all of those years ago, did in fact find blood vessels of a Tyrannosaurus Rex.
Wow.
With some blood residue left over. Confirmed.
Amazing.
But age, pressure, and heat had converted the proteins in the blood and those vessels into something else entirely.
Oh.
So they were no longer resembling a T-Rex protein, but something else. Proteins rely entirely on their shape for their function, and heat and other chemicals will change their shape. And that's what had happened. They were no longer viable. We couldn't even begin to guess what original shape they were in either, which is a shame. And also, apparently there was some human contamination in there along the way throughout the years, because it was 25 years old at that point. So
we're not going to be de-extincting the T-Rex anytime soon.
No.
De-extincting? You know what I mean.
De-extinct. But it's genetic manipulation from blood is nigh on impossible, which is not unexpected. So to come to a kind of the final bit on bringing back dinosaurs, talking about cloning, it's very tricky to clone an animal of the same species, let alone 2 million years apart. Same issue with the mammoth, a few 100,000 years apart, but this is literally 67 million years. What has been done is something called genetic bracketing, where you look at the animals alive today which surround the dinosaurs, or a group of dinosaurs. So you've got crocodiles, other reptiles, birds, to try and figure out what the differences are, what the similarities are, and because dinosaurs fit snugly in the middle, what the dinosaur genome could have looked like, what its structure was, how it may have functioned. So birds, theropods, sauropodomorphs, which are kind of the sauropods, the long-necked ones, were found to have small genomes, which I think is incredible. Rebecca O'Connor from the University of Kent in 2018 managed to map the DNA of different chromosomes in modern birds, reptiles, and worked out the structure of dinosaur genetics. And her conclusion was they had 40 chromosome pairs. In turtles, there's normally 33. In humans, there's 23. So by building what the genome looks like and where the genes should be and what the chromosomes should look like, we don't know what's in them, but we kind of know what they look like. We start to understand why there were so many different types of dinosaur.
Okay.
But for all of the work that is done and figuring out the genetic architecture, seeing what the chromosomes look like, figuring out how many there are, we still don't know what's in them, and we still can't clone them. And without DNA, we don't even have a chance to begin that process. Let alone if you could bring one back via the Jurassic Park method, gut bacteria, diet, behaviour. I mean, some of them were coprophagous, which means they would eat the poop of their parents to get good gut bacteria. But without previous dinosaur poop, how would you know?
Yeah.
What would the theropods eat? What the meat eaters eat? Because are you going to feed them rabbits? I mean, all sorts could go so horrifically wrong in terms of their immune system. We have literally no idea.
Yeah, there'll be new pathogens around, right? Now, compared to what there was
exactly.
then.
They
get sick very quickly.
Get a common cold and they would die. They wouldn't be able to build up their immune system from the parents. No chance of creating any sort of ecological background that could have even been very vaguely similar. And again, circling back to the behaviour. I guess the only way we can do it is like with the mammoth, we can genetic backtrack. We can take a chicken and we can turn on some genes which have gone to sleep and make them grow teeth.
Is that where we're at? Teeth.
Which has been done. That's what that we did. That we managed to turn on the genetics that had previously gone to sleep, dormant genes from a previous dinosaur past in these chickens, and the embryos started to develop teeth in the actual jaw.
I don't know about
because the beak isn't part of the jaw.
I don't know about you, but that's not really what I think of when I think of dinosaur.
No, and also, they also figured out how to make a slightly longer tail.
Okay, baby steps, I guess, if we're going to do this.
But that's as far as we got, and also they had to terminate the embryo in that one because it was a chicken with teeth, and chicken are not meant to have teeth. It would have been
ethically dodgy. Yeah, you can't really let that out.
Yep.
Yeah.
So that's as far as we got with recreating the dinosaur in terms of the ancient Cretaceous beasts running around. So overall, the conclusion to the mammoth dinosaur conundrum: you can't only have a few individuals because they'll get lonely. Who gives birth to it, and what's the ethics behind that? How many tries is too many tries? How many deaths is too many deaths? Repeating them again and again. Is there a space for them anymore? Because the mammoths, sketchy if we put them in kind of the tundra regions. Dinosaurs absolutely do not have a place on this planet anymore. We don't know how they act. We don't know how they behave. We don't know what they eat in terms of what we could give them today. Scientifically, maybe keeping those bits in a lab is better, and we can get more from that rather than the effort of creating a dinosaur or a mammoth. And I mean, entertainment or science, that's where it comes down to in the end. That is going to be the end of our first episode on de-extinction and bringing back extinct animals. In the next episode, Becca will continue this train of thought, looking at modern de-extinction, as well as some conservation efforts which are currently going into play today. Thank you very much for listening, and catch you in the next episode.